All right, getting started on 6-4. 6-4 is a continuation of systems of equations, but this time we're doing inequalities as well. And so we're going to use matrices to solve these. So let's jump in and just see what this is about. Use augmented matrix for systems. So an augmented matrix is literally just the coefficients of an equation. So y'all know how like in the other 6-1, we might have had like 2x plus 4y equals 8, and then 3x minus 2y equals 10. And we said solve this. Well, you had to identify the coefficients first. Right. And then you could write those in a matrix. 2, 4, 8, 3, -2, 10. This is called a matrix. And the dimensions of a matrix basically means the size. So dimensions are always written as row by column. So how many rows and how many columns? Okay. So there are 2 rows, row 1, row 2, and there are 3 columns, column 1, 2, and column 3. So the dimension of this, the dimension will be a 2 by 3. 2 rows, 3 columns. That's just fundamentals of understanding matrices. So in this case, how many rows are there? 3 rows. How many columns? There are 2 columns. So this is a 3 by 2 matrix in terms of the dimension. Here we have row 1, row 2, column 1, column 2. So this is a 2 by 2 matrix because there are 2 rows, 2 columns. Yep. So that's just understanding dimension. So how do you write a matrix from in a system of equations? So like, for example, in 6-3, we had 3 equations with 3 different variables. And so there are 2 different types of matrices that we can pull out from this. One is called the coefficient matrix. And with the coefficient matrix, you just take the coefficients of X, Y, and Z, and that becomes a coefficient matrix. With the augmented matrix, we take all the numbers, coefficients, and the constants. And sometimes you'll see a line drawn down the to delineate between which are the coefficients and which are the answers. So like if I were to write the coefficient matrix here, I would just write the coefficients of X and Y. So I have 3, -2, -7, and 2. But if I were to write the augmented matrix, I would write 3, -2, 4, -7, 2, 1. So just being able to write these out is what the first tool is. Can you write a coefficient matrix? Can you write an augmented matrix? And do you know the dimensions? So the dimensions of our coefficient matrix are 2 by 2 because there's 2 rows and 2 columns. Whereas the augmented matrix is a little larger because there's 2 rows, but there are 3 columns now because we included those constants, which were the answers. Moving right along. It says identify matrices that are in row echelon form. So again, this is just another one of those things that we're learning. Row echelon form. So to solve linear systems with augmented matrices, the convenient form is row echelon form. Row echelon form says that basically the elements below the main diagonal are all zeros. And the main diagonal has only ones in it and possible zeros. So a main diagonal is going to be the main diagonal from bottom to top corner, from bottom corner to top corner, from bottom corner to top corner. Okay, we have to see which of these only has ones and zeros and where all the other numbers below that diagonal are all zeros. Okay, so it's a, oh my God, I did this so backwards. Lord, I'm so sorry. I just messed it all up. The main the main diagonal is from top to bottom, not from bottom to top, Ariel. So sorry, y'all. Delete that part. Let's do it for real. Main diagonal from top to bottom. So sorry. And then the entries below that have to be all zeros. So in this first one, this is the main diagonal and it's all ones, and the elements below it are all zeros. In the second one, it's all ones and possible zeros. See that? And all the entries below it are zeros. So that would be yes. Whereas here, the main diagonal has a 7 in it. So unfortunately, this is not in row echelon form. And not only does it have that 7, but it also has this 1 here. And these are all supposed to be zeros. So it's not in row echelon form. So use the matrix given in row echelon form and backward substitution to solve the system. So again, the main diagonal is ones and zeros. All the ones below it are zeros. So what this tells us, this is my X column, my Y column, my Z column, right? So using the backward substitution, this means Z, 1Z equals -5. So that's already a part of my solution. I know Z, we're looking for X, Y, and Z. Z is -5, okay? So if Z is -5, we can take -5 and substitute it into the second equation. So I guess the first thing probably that you'll want to do is rewrite these as equations. So this is 1x plus 2y plus 1z equals 16. This next one is 1y, because there's no x right here, minus 4z equals 30. And then my third and final equation is 1z. What am I doing? Equals -5. So I already have my z equals -5. Now I can take this -5 and plug it into this next equation. So we can solve for y plus 20 equals 30. Subtracting 20 from both sides, we get y equals 10. So now we know 10. And then taking my x and my z and my x to the first equation, 1x plus 2 times y, well, y is 10, plus 1 times z, well, z is -5, equals 16. So we get x plus 20 minus 5 equals 16. X plus 15 equals 16. So subtract 15 from both sides, x must equal 1. So there's my solution. Now that's by hand, and we haven't been doing anything by hand in this entire chapter. So what we'll want to do is let's look at this from a calculator standpoint, okay? Okay, so from the calculator standpoint, what I'm going to do is I'm going to clear this out, and I am going to go to my main menu, simultaneous equation solver, 3 equations, 3 unknowns, and I'm going to type in my function as I see it using my coefficients. So 1, 2, 1, 16, 0, 1, -4, 30, 0, 0, 1, and -5. So I just typed in those coefficients and those answers from my augmented matrix into my system solver. And I'm just going to click solve. And there's my answers, 1, 10, and -5. So again, I don't have to do this by hand, although you totally can, okay? That's called backward substitution, or you can just use your calculator and solve your equation simultaneously. Okay, so let's look at another one of these questions. So again, it says use the matrix and solve it. I'm gonna do this in my calculator because why not? So I'm gonna go back system and I'm gonna clear it all out. There's 3 equations and 3 unknowns, so we're good to go. Typing in my system. I got 1, 0, -4, -3, 0, 1. Uh-oh. -3, 0.5, 0, 0, 0, 4. That's weird. Like, how can a bunch of zeros equal a 4? So I already know something's gonna be jacked up about this one. So I'm gonna go ahead and click solve. No solution. That's the answer. Like this bottom row doesn't make any sense. 0, 0, 0 equals 4. So 0 z's equal 4. That doesn't make any sense. 0 y's, 0 x's. That doesn't make any sense. So the answer is no solution because 0 could never equal 4. And we'll do it again. In example 4. So let's go back. I'm going to go back to system and I'm going to clear it out and type in my answers one more time. 1, -1, 2, 8, 0, 1, -4, 2. And then I got 0, 0, 0, 0, 0, but all zeros on the bottom. So this time, maybe there's infinite solutions because 0 does actually equal 0. That means we don't have a solution for for z. So let's go ahead and solve. We don't have a particular solution for z. So here what we're going to do is we're going to say z equals z. That tells us that there's an infinite set of solutions because we can choose what z is, and then that will allow us to scale up our x and our z. Our x and our y. So there are infinitely many solutions. Whenever you end up with 0 equals 0, that's what that means. Okay. Oh, and if they wanted to write it as a triple, it is actually given to you in that equation. So you can write x is 10 plus 2z, y is 2 plus 4z, and z is z. And that's how it looks when you write it as a triple. Okay. All right. Let's keep going. Solving the system with the matrix. So I, again, am not asking you to do anything by hand. So if they give you a system and they say, hey, solve it, you don't actually have to do any of the Gaussian elimination things. All you have to do is solve it using your calculator. That's all I'm looking for, okay? So all of these examples, all of this breakdown for example 5 is not actually necessary because we're not going to do it by hand. What we're instead going to do is we're going to take this calculator, we're going to take this calculation that was given to us for number 5, and we're going to just put in the calculator. So clear it out. 3, -3, 9, 15, 0, 1, 2, 1, 0, 1, 1, 2, and solve. There's your answer, 11, 3, -1. If I skip down to slide 10, that is exactly what it was asking me for, 11, 3, -1. Okay. Now, can you do this by hand? Absolutely. Am I going to teach you how to do this by hand? No. And the reason I'm not going to teach you how to do this by hand is because we've actually taught this in Algebra 1 and in Algebra 2 through elimination. That this is all elimination. So if you do want to learn about elimination, I can put other videos on our channel for you to toy with that. But because our test is next Monday, I think it's more important that you learn how to do this in the calculator. So example 6 is one of the ones that's the same, but it's given to us as a system. So we need to, again, use that knowledge of the coefficients to create the augmented matrix. So in here, we'll have 1, 1, -1, 2, because that's where these came from. -2, 1, 1, 3. 0, there is no X. 1, 1, 9. And that is your augmented matrix that you're going to use to solve the system. So you're going to go back into the equation solver and type in those numbers. And solve. 3, 4, 5 is my solution. Let's see if that's what we end up getting. So for number 6, the answer is 3, 4, 5. That's your order triple. Okay. And the final one here, it's the exact same thing. So we're going to be writing this as a matrix. 2, 2, 1, 2. -1, -1, 2, 4. -2, 1, 1, -1. And we're going to type that in our calculator. I'm come in system clear. 2, 2, 1, 2. -1, -1, 2, 4. -2, -2, 1, 1, -1. And the answer is 1, -1, 2. Just like what we see. So again, I told y'all the calculator is gonna come in handy on this last chapter, and I think it really has. That is the end of 6.4. Be on the lookout for 6.5.